So we are starting a new topic, basically triangles. And so we have a few problems here that are dealing with angles on the interior, because that is the first question, or that's the first thing we need to cover as far as triangles. How can I use the properties of a triangle to find the missing angles in the triangle? Okay, so there's two definitions here that we need to realize: is the sum of the interior angles as well as the sum of the exterior angles. But we'll get to that. Let's start with one piece at a time. So we're given an example, and it has angles on the inside. And the first question we want to know is, how can I find the third angle in a triangle if I know the other two angle measurements? Okay, well, we can find those third angles by using the definition titled sum of the interior angles. Okay, so whatever I'm highlighting on here, I encourage you to write down in your notebook, because these are important things that you should remember. Okay, and you're going to use these things that I highlight or write down for your reference when you're doing assignments or you're looking back over to study. Okay, so the essential question of today is, how can I use the properties of a triangle to find missing angles in a triangle? And then more specifically in this case, how can I find the third angle in a triangle if I know the other two angle measurements? Now, we have a lot going on in these four examples, and I'm going to try to explain them very quickly so that you're not watching a 20-minute video. So please follow along. If you get lost, please slow it down, rewind, go back, and just see what I'm doing. Okay. So the sum of interior angles, the first thing you should know is the sum of the measures of the angles of a triangle is always 180 degrees. So no matter what, the sum of the angles inside of a triangle is always 180 degrees. Please write that down. That is so imperative. Okay, that is so important. Write that down. The sum of the measures of the angles of a triangle is always 180 degrees. And we can use that knowledge to help us solve for missing variables or missing angles. Just like in example number 1. It says, what is the value of x? Well, looking at this picture, which I do encourage you to redraw in your notebook, looking at this picture, we can see that x is an angle on the inside or interior of our triangle. So is 95, so is 40. So I can find their sum to be 180. Okay, or I know that their sum is 180. So I'm just going to take x plus 95 plus 40 is equal to 180. And at this point in the year, I'm not going to continually go over how to solve for x. This is a multi-step equation, okay? You know, you combine like terms. Okay, I bring down my x. My like terms give me 135. That's equal to 180. I subtract 135 on both sides, and I'm left with 45. And that's my answer. That's how I would solve for x. So let's recap what we did. The question is, how can I find the third angle in a triangle if I know the other two angle measures? Pretty much by using the sum of the interior angles of a triangle, which means all the angles on the inside of a triangle, no matter what they are, add up to equal 180. Okay? Let's look at number 2. What is the value of x? Once again, x is on the inside, but I don't have any other angles on the inside. But I can find out what those are. Because I'm given some extra information, I can use that prior knowledge to solve this. Okay? We can see these little arrows indicate that these two lines are parallel. and they're also being cut by a transversal. Okay, we'll use a different color for that. They're being cut by a transversal. Okay, remember in parallel lines cut by a transversal, you have acute and obtuse angles. Okay, so right here on this parallel line cut by transversal, I have 85 degrees, which is acute. So of course this would be 85. This would be obtuse, and so this entire thing right here will be obtuse, and I don't need that. Okay. This is also 85 because that's acute. So we found one of the angles on the inside. This is 85. This is obtuse, and this is obtuse. I'm not going to assume that 130 is equal to 130. I can't assume that, okay? I cannot assume that. We just needed that information to figure out that first angle. There's more than one way to solve this, but I'm just showing you the most efficient way. I can solve for this angle right here, given that 130, just by doing 180 minus 130. Now, why do I do that? I did that because this straight line right here is also equal to 180. And 130 and this other angle right here, so this right here is a linear pair, which means that these two angles add up to equal 180 as well. I know 180 is like a recurring theme in geometry. Okay, so when I do 180 minus 130, I end up with just 50. So this angle right here is 50. Okay, so in my triangle, if I were to redraw it, it's going to look something like this. I got 85, X right here, and then 50. Okay, I'm going to do X plus 85 plus 50 is equal to 180, because that is the sum of the interior angles. Once again, combine like terms. I get X plus 135 again, and that's equal to 180. And then, of course, just like in the last one, X is equal to 45. Okay, the key thing here I need you to remember is that no matter what you're looking at, the sum of the measures of the angles of a triangle is 180. Always remember that. Always remember that. Okay? Example number 3 and 4, we're going to use that same exact method. Okay, they just ask a little bit more of us to do in this example. So in this example, it says, what is the measure of angle A? Angle A is equal to 4x minus 4. So I have to first figure out what x is and then plug it in order, or substitute it in order to figure out what angle A is. What can I use to figure out or solve for x? Because I don't have to make an equation to solve for x. So what's that equation? It is the sum of the measures of the angles of a triangle is 180. So I'm going to take all my interior angles, add them up, and equal them to 180. When you solve this, you'll get, or you go ahead and solve this. What is x? Very good. It's 11. So now I can take that and plug in or substitute x in to A. Okay, so A is, remember, 4x minus 4. So 4 times 11 is minus 4. That's equal to 44 minus 4, which is equal to just 40 degrees. And that is the measurement of angle A. We did find x, and that was what our original goal was, but because the question asked for one more additional step, we had to solve for that additional step. Okay, and lastly, in number 4. Look at number 4 here. It says given line segment AB is parallel to DC. So the first thing I'm going to do is highlight my parallel lines here. Okay. And they got 2 transversals, but I'm not going to confuse you. Okay. Because they're parallel, their bases are parallel. And I got this angle, which is vertical to this angle. I can assume that these are pretty much the same exact triangle, just flipped. Okay. So if 35 is here, it would be here too. If 40 is right there, it would have to be here. Okay, so if I were to redraw any of these triangles, and X goes right here, of course. If I redraw any of these triangles, I'm going to draw the top one. You have X, 40, and then 35. Remember, those are all interior angles, and their sum is equal to 180. So I'm going to do X, 40, and 35, and equal that to 180. Combine like terms. Now I have X is equal to 75, equal to 180. Okay. I'm going to do (180) minus 75, which is 105. So X is equal to 105 degrees. Easy as pie, flying high in the sky. So what about exterior angles? Well, what is an exterior angle? Okay, I'm going to write this down here. An exterior angle, I'm going to just draw it right here, if you don't mind. I'm going to type it in. An exterior angle is basically an angle on the outside okay, that's what I'm going to put right there. Angle on the outside. That's all it is. That's all it is. An angle on the outside. Okay, so an exterior angle, to answer that question, what is an exterior angle here? An angle on the outside. That's all you need to write down. An exterior angle is an angle on the outside. So how do we find the measure of an exterior angle given the 2 opposite interior angles? Well, we can use the exterior angle theorem, which pretty much says the measure of an exterior angle. Let me go ahead and write that there. So I'm going to zoom in here so we can all see. Uh-oh. A little technical difficulties. That's all right. The measure of an exterior angle of a triangle is equal to the sum of the measures of the 2, we're going to say, non-adjacent interior angles. I'm going to use that. I'm going to use red for that one. Non-adjacent. Non-adjacent. Okay? Which means it's not close or it's not touching that exterior angle. So those 2 angles are not touching that exterior angle. Let's look at that first example. Let's find the value of X. We have 2 angles on the inside here, and they are not touching my exterior angle. So they're not touching this angle on the outside. Therefore, they can add to equal whatever that exterior angle is. Okay, I get 130. And that's it. So what is an exterior angle? Very good. So let's apply that same theorem, as they call it, to these. Okay, it's simple. It's easy, y'all. It's easy. Just take your time and just pay attention. You got it. Let's solve for X. All right, I have 3x plus 70 on the exterior, and then I have these two angles on the inside of my triangle, which are not even touching or close to that 3x plus 70. These two angles right here. So that means I can add those to equal that 3x plus 70. I'm going to zoom in so that you can see what I'm doing. Okay, so I'm going to take 56 plus that 4x and equal it to 3x plus 70. Because that's literally what our exterior angle theorem is. The measure of an exterior angle, I'm going to highlight that because you need to make sure you know that. The measure of the exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So that means I can add those two non-adjacent interior angles to equal my outside angle, which is how I developed this equation here to solve for x. Okay? I'm going to put all my x's on one side. So I end up with 56 plus 4 minus 3 is just x. That's equal to 70. Put that 56 on the other side. So I have 70 minus 56. I'm going to put that in the calculator. So 70 minus 56. And I get 14. I'm going to check my question. Is that all they're asking for? All they wanted to know was x. So we're done. If that was too confusing, just go back and look at it. Just rewind. It's a video. Ooh, Mr. Hutchinson, this is a whole lot going on here. Hey, let's take it one step at a time. What's some things that they give us in this example? They give us these parallel lines. They did not just put that there for decoration. They put that there for a reason. Pay attention. Pay attention. All right? And it's also cut by this transversal. So I can use that knowledge to find some other stuff, right? I can use that knowledge. So right here I have a 57, which is acute. So this is also a 57. Now I have my two interior angles that are non-adjacent to that 111, and therefore I can add them to equal that 111 because that is the exterior angle sum theorem. Okay, so I'm going to take 57. Actually, I'm going to take x first. I'm going to put x just so we keep things consistent. X plus 57 is equal to 111. And if you did not understand why I highlighted those parallel lines, it's because of these little arrows. I knew immediately by looking at those two arrows that these two lines were parallel, as we learned in that last unit. Okay, and then they also have that big line that cuts and crosses between them. So that's a transversal. Remember on the XO practice, we said that a transversal intersects two parallel lines. There you go. And that's how we knew that 57 could go down here. The actual definition is alternate interior angles, but in case you forgot those, remember you label your A's and your O's, acute and obtuse, and then you would have figured out that 57 is right there. So I'm going to subtract 57 from 111 now. 111 minus 57. X is equal to 54. I'm going to circle that one just to be extra. All right. So we pretty much answered both questions. The first question is, how can I find the third angle in a triangle if I know the other two angle measures? By using the sum of interior angles, which means all those angles add to equal 180. And then when you get to exterior, use the exterior angle theorem, which says the measure of the exterior angle of a triangle is equal, so the exterior angle is equal to the sum of the two non-adjacent interior angles. Okay? And if you understand these two things, you know how to answer the essential question, how can I use the properties of triangles to find missing angles inside of triangles? If you have any further questions, feel free to ask, but I will say that there is a quiz coming up after this, and it's basically the answers to all of this. Okay. The first example is going to be this example. The second question is going to be this example. What do we get for each answer? Okay. I'm not going to make it too difficult. Just want to make sure that you watched this video and that you understand. Okay. All right.